finished 9.1 through 9.3. Now it is time for section 10.1, which is a part of chapter 10, which is all about geometry. Okay, so geometry. Just so you know, the geometry that we are working with is what we call Euclidean geometry, discovered by Euclid. Okay, this is not the only geometry that exists. Just want you to know about that. There are many geometries that are out there that exist in our world. Some of them are made up of a ton of points, like Euclidean geometry that we know and care about. Other geometries are only made up of a few points. For instance, I have studied a geometry called Fano's geometry before. It only consists of 7 points, and there's not much to that geometry. So some geometries are very, very small, like Fano's geometry. There's a geometry out there that is sometimes called Pac-Man geometry, or another name for it is taxicab geometry. Kind of an interesting geometry where circles look like squares. Because in Pac-Man geometry and taxicab geometry, if you know the game Pac-Man, Pac-Man can only move up and down and left and right. There are no diagonals or anything like that. He can't curve either. He moves in a straight line up and down or left and right. So if we made a circle using Pac-Man, he would move up, and then he can move left or right. Let's just say he moves to the right, then he can move down, and then he can move back to the left, and that would be a circle if it puts him right back at the starting spot. Okay, so and that circle would look like a square. The same thing with taxicab. If you kind of look down at like the grid of a city, taxicabs move up and down the street, or they can turn, left and right and move horizontally. Okay. There are other geometries that exist, such as what we call spherical geometry. And what's interesting about spherical geometry, it's all based on a sphere, obviously, hence we call it spherical. But what we know about triangles, like for instance, in our Euclidean geometry, all of you know that triangle angles inside, the interior angles, all add up to 180 degrees. You know that. That's not new. But in spherical geometry, the angles inside a triangle could add up to less than 180 degrees or more than 180 degrees. It's quite interesting how that works in spherical geometry. Take a look at it. Look it up. Go to Google and type in spherical geometry triangles. And you can see different pictures. Again, those angles inside, they don't add up to the usual 180, 180 degrees like it does in Euclidean geometry. But what's important to know about all these geometries, they all share common features. The first feature being that they all have what we call undefined terms. And I would have had a lot of fun with this in class, had we had you guys there talking about undefined terms, which you'll learn about here in a second. But they all have undefined terms. And then from there, you start getting statements that are understood to be true. We call those postulates. And then from the postulates, we start getting theorems. Okay? Theorems are things that we can use with those postulates and those undefined terms to help us create other objects that we can prove in our geometry. And you're going to see that as we go through our geometry unit, how everything is really developed from the 3 undefined terms that we're going to talk about here in a second, 2 of which you can already see on my screen. Okay? So it's interesting how there are other geometries out there. They produce different results, but they're all made up of the same thing. You have these things called undefined terms. You've got some given truths, which we call postulates, and then you got theorems and things like that follow from it. Now, I know many of you are freaking out because you heard the word theorems and postulates and things like that. We are not doing proofs. That is not what this geometry is about. This is all surface level geometry, where you're going to be dealing with angles. You're going to be dealing with some parallel lines. We'll talk about triangles and then polygons. And we're going to talk about area, volume, surface area. We'll also talk about perimeter. Okay, so we're going to be dealing with some basic ideas. So don't freak out. I'm really good at teaching geometry. I've taught geometry many a year when I was a high school math teacher. So I know geometry like the back of my hand. So trust me when I say, I promise this is going to be very, very painless. Okay. We're going to go we're going to be surface level on this. Okay. We're not diving in too deep to these concepts. So 10.1, kind of give you a preview. We're going to talk about these undefined terms, which lead us into angles, which will then lead us into angle relationships and parallel lines. That's what 10.1 is about. So let's do this thing. So the first thing I would do in class is I would talk to you about a point, because our basic geometry starts with a point, okay? And I abbreviate point PT. And I would come around and I would ask you guys, what is a point? And many of you are like, it's a dot. And I would be like, yes, you have just given me a description of a point. But I will again ask you, what is a point? And I would usually have someone that I call into the class, and they would sit there and struggle, just looking at me like, Ms. Armstrong, is a dot. And I'd be like, yes, it looks like a dot, but what is it? Okay, that's a description. Okay. So, and that's okay. You know, you're meant to struggle with this. The same thing with a line right here. So a line, okay, again, most of you would say, it's straight. I'd be like, cool, that's a description. But what is a line? Okay. And so many of you would basically be describing what it looks like. And then again, here's what a point looks like. But for us, points, lines, and then the third one that we'll talk about is a plane. Okay. Points, lines, and planes are undefined terms. We can't define them. Okay. Because most of the time when you define them, you end up using the word in the definition. And that's a poor definition. You can't define the word you're defining with the word itself. That doesn't make sense. Okay. So a point, we're going to basically just talk about what we know about it. Okay. Not a definition, but what we know about it. So like what you guys told me, it's a dot. But more specifically, a point has no width, no length, no thickness. So what I gave you right over here, this dot with the capital letter A representing point A or PT A. Okay, we use capital letters for points. This dot is way, way too big. That's not really what a point looks like. And even if I take it and shrink it down like this, even that dot is still too big because I can measure the width, the length, and the thickness of that thing. Okay? That's still way, way too big. And I can't even get any smaller than that. An atom, you can be like, oh, an atom's like a point. You know, like the atom of elements and things like that. Even that is still too big because you can measure the width and the length and the thickness of an atom. Okay? Points are basically dimensionless. All right? But in geometry, because we kind of got to be able to see them a little bit, we label them with a dot. And it's a capital letter. Okay? Down here in class, like I said, I would ask you to define what a line is, and we would end up finding out that, oh, Mr. Armstrong, I can't define a line. I'd be like, yeah, that's right. You can't define a line. Okay? So you can see what a line looks like right here. It's got two arrows and two points on it, A and B. Down here is a way to name the line. We'll talk about that here in a second. But a line for us, here's what we know. It connects two or more points. Okay. It has no curves. So, in other words, meaning straight. But we say no curves. It has length, but no width and no thickness. Okay. It has length, but no width and no thickness. All right. So this is what we take for what we know about a line. Again, that's not a definition. This is just what we know about it. Okay? So lines actually have infinite amount of points on them. Okay? They have infinite amount of points. But most of the time when we draw a line, we usually just use 2 points. Because to draw a line, you need 2 points. All right? Down here is the name of a line. So you can call this line AB. Start at A and move to B. Or you can call it line BA. Start at the B and move to the A. It doesn't really matter. The order doesn't matter. Here's a way to speed up the naming of a line. You can write AB and put the line symbol above it, or write line BA and put the line symbol above it. Either way, when you name a line, you need 2 points. Okay? 2 points to name a line. All right. And then last but not least, a plane. All right. And if we were in class when we talk about this, I would have you guys in class look around and tell me points, lines, and planes that actually exist within our classroom. But before we get to that and kind of talk about that, because I'll let you know what you guys would generally point out in the classroom. A plane, here's what a plane looks like. Okay. Here's how we name a plane. So notice that we have this giant bold letter Z. Sometimes when you guys look at planes, you'll see a bold letter in there that has no dot associated with it. That is the name of the plane, so we can call it plane Z. Or they will take 3 points that are in the plane and use those to name. So like plane ABC. Or it could be plane CBA. Or it could be plane CAB. Okay, as long as you have 3 points and it doesn't matter the order, you've got a plane. Now, what do we know about a plane? We know this. It has length and width and no thickness. Length and width, but no thickness. Other things about planes, and I mentioned this with lines, these arrows mean that it go on and on forever. So this thing's going to keep stretching to the left of my screen. This line is going to keep stretching to the right of my screen, and so on and so forth, and off my screen, all the way through my bedroom furniture and the wall that's over there on the right side, and over here through my wall and through the hallway wall, all the way over through another bedroom and out into the street and everything like that. Lines keep going on and on in both directions on either side. Okay? They go on infinitely. The same thing happens for planes. These sides right here extend this way. These sides up here extend this way, and diagonally it goes. So this whole screen right here that I'm outlining, this is a plane. And this plane can extend off my computer, going up and down and to the left and to the right. Okay? Planes continue on and on forever. Okay, so if we were in the classroom, things that you guys would point out, most of you guys would look at the ceiling and you would see the lattice that is on the ceiling. So you can see that our ceiling is made up of, I believe they're rectangular little boards, and you could talk to me about how you have lines up there that hold the rectangles up there because there's little braces for each rectangular square. And you can see those lines extending left and right and east and west, north and west, whatever you want to call it. You can see those lines extending up there. You would say that there are points where those two lines meet. Many of you would say that there are points in the corners of a room. Okay, you would talk to me about planes, how the ceiling is a plane, and our four walls that surround us, and the floor is a plane. So you can see lots of planes and points and lines that affect us every day. Okay, so these are our 3 undefined terms. We take them as with this information, no more, no less. We just accept they exist, but we can't define them. Okay. Now, from here, we take those points, lines, and planes, and we can start talking about objects, where we put these objects together and we can actually define them. Okay, so these right here, line, segment, ray, and angle, are objects that are made up of this information. Okay, so for instance, a line segment. The definition of a line segment is that it is a line with 2 terminal points. It is a line with 2 terminal points. So you can see that my line has a length. And what we mean by terminal points is that it has a beginning and an end. Think about it kind of like a race. Okay? Races have a starting mark and an end mark. Okay? That's like a line segment. My race begins at B and ends at C. Or maybe my race began at C and ended at B. Okay? line segments have a beginning and an end. They do not continue on indefinitely. That's what it means by a terminal point. Okay? So, naming a line segment, just because I like to always keep you up on that. And again, this should not be anything new to most of you. So you can call it line segment BC, or you can call it line segment BC and use the symbol of a line segment above it with the B and the C. Again, order doesn't matter on this, so I could have this as a C then a B, and a C then a B right there as well too. Okay? Line segment. Rays, again, this is another creation of a line. An array is a line that has an initial point and then shoots off in one direction. That's a ray. It is a line with an initial point and it shoots off in one direction. Most of the time, rays are, they look like this, but they don't have to. The ray could be shooting off in a diagonal direction, or it could be facing the other way, or it could be shooting down, or it could be, shooting straight up, or in that direction. Rays can point lots of different directions, but the fact of the matter is it has like a beginning and then it shoots off in a direction. Think about this like Forrest Gump. When he took off running in the movie, he was just like, I was running. Me and Jenny, we like peas and carrots. Okay. Forrest, he started at Greenbow, Alabama, and then went running towards B. Okay. That's like Forrest Gump. He just went running and he wouldn't stop. He was just like, he started here and he's like, I'm just going to go run. Okay. So think about a Ray kind of like Forrest Gump. He starts running and then he just doesn't stop. Okay. So down below, naming. I want to talk about naming because naming is important. Notice it says Ray AB, or you can use the Ray symbol. And the Ray symbol always points to the left if you're naming it with the Ray symbol, AB. Notice that A came first. The reason why the A came first is because that's where we start. And then B is some town along the way. So we got this point B. So, it'd be like Forrest Gump running through the town of Des Moines, Iowa. So you could say, start in Greenbow, Alabama, and then ran to Des Moines, Iowa. Okay? So you started at Greenbow, ran to Des Moines, Iowa. As long as you give me any other point along the ray, that can be the second point. Okay? So this is where you start running. This is some town that you ran through or whatnot. We do not name this ray BA. We do not do that. That would be incorrect. So we are not doing this. That's wrong for this because this tells you that B is the initial point and then we ran towards A. So this is incorrect. All right. Now, since we have rays are what we use to make angles. Okay? So the angle over here, the definition of the angle is two rays that share a common initial point. Two rays that share a common initial point. That's all an angle is. So you could think about it as Forrest running again from Y to Z, and then he's got Jenny that runs from Y to X, because that's Jenny. She always goes the opposite direction of Forrest. Okay, so that's what an angle is. An angle is two rays that share a common initial point. Now in class, I would ask you, what is this initial point right here called for both of these rays? Or in other words, what's the special name of this initial point in an angle? Some of you would look at me like I'm stupid, and it usually takes a couple seconds, but eventually we find out that that is what we call the vertex. Okay? So that common initial point for these two rays is what we call the vertex. All right, super important. So two rays that make up an angle. See, everything we've talked about contains lines or pieces of lines, points, lines, or a piece of the line, points. And then here we're taking two lines and we're putting them together. See, our geometry is starting to take form, to take shape. But again, it's all based off of this information, points, lines, and planes. That's where it all starts. That's what it all boils down to. So an angle, how we name those is Come here, you. You can write the word angle and then X, Y, Z. Or you can see the angle symbol. You're going to see this symbol a lot. Looks like a less than symbol, but that's an angle symbol. Most of the time, you'll see me write my angle symbol with a little arc through it, so that way you don't confuse it with the less than symbol. Okay, so there's my angle symbol. You could also name it ZYX. Look at the order on these. These two are a proper order. What do you notice about these two angle names? Hopefully you saw or can see that the Y value is in the middle. The vertex of an angle always goes in the middle when you are naming them. The vertex always goes in the middle when you are naming them. And then some other things that you might see out here. They might have a number inside your angle. So another way to name this angle is we could call it angle 1. Others that they might use is if this is the only angle that's possible at Y, then sometimes they name it just for the vertex. So they might just call it angle Y. If that's the only angle that exists at Y. Okay? So just some other ones just to be a heads up. I know I use the numbers a lot when we go through this, and our book does too. So know that when they use a number, they're talking about the angle that is inside that, the angle that surrounds that number. Okay? All right, so our geometry is getting bigger. Okay, we've got some different objects we can work with now. Lines, line segments, rays, angles, points, planes, 6 objects. And from here, we can start to now build relationships and start to understand some terminology. So let's talk about angles. Okay, there are 4 types of angles that we want to discuss and know about. Hopefully you know what they are. One of them is acute angles. Okay, acute angles, this means measure of the angle. Okay, so an M in front of an angle symbol means you're talking about its measurement. Angles are measured in degrees for us, and acute angles are angles that measure between 0 and 90 degrees. So if I have an angle that measures 12 degrees, that's an acute angle. And an angle that measures 30 degrees, that's an acute angle. If I have an angle that measures 0 degrees, I know that seems weird, but an angle that measures 0 degrees, that's not an acute angle because 0 is not a part of this. You are between these two values. Okay? Well, what do I have? What do I call an angle that measures 90 degrees? Hopefully you all know that to be the right angle. I abbreviate right angles also RT because I'm lazy. So any angle that measures exactly 90 degrees is a right angle. All right. We have obtuse angles. Okay. Obtuse angles are any angle that measures between 90 and 180 degrees. Any angle that measures between 90 and 180 degrees. So 110 degree angle is obtuse. 145 degree angle is obtuse. 180 degree angle is not obtuse because it is not a part of this. You are between these two values. So what if I have an angle that measures 180 degrees? That's the 4th one, and we call that straight. Or angles that measure 0 degrees are also called straight angles. Okay? Most of the time, though, we don't call them 0 degrees. We call them 180. All right? So any straight angles measure 180 degrees, period. All right, so what you're going to see in your assignment, just some general questions, they're going to give you a protractor, okay? And they're going to say, find me the measure of angle BAF. Or find me the measure of angle FAC. So all they want you to do is read the protractor and tell me how many degrees that angle measures, okay? So I'm going to do the first one with you, just to walk you through. And then I want you to do the second one on your own. So BAF, I'm going to mark that angle. It starts at B. It travels to A, and then it goes out to F. Wow, that's horrible. Let's redraw that little ray right there. And then it goes out. Okay, not let me write. Come on, you. All right, let me go. Here we go. A little bit better. Still wobbly, though, towards the end, but that's fine. All right, so there's our angle. They want to know how many degrees is this. Here's how you can do it. We like it if our angles start at 0 and then open up, but they don't. Okay? So this guy starts at 20. It ends at 130. All you got to do is take the largest angle or the largest measure and subtract the smallest measure from it. Plain and simple. So 130 degrees minus 20 degrees gives us 110 degrees. And as I expressed in sections 9.1, 9.2, and 9.3, labels, labels, labels. From here on out through the rest of the year, labels on everything. So this is a 110 degree angle measure. Again, all you do is you take the large measurement minus the small measurement. Okay? The large measurement should always be the left ray. The small measurement should always be the right ray. Okay? That's all you got to do to find the angle measure. Go ahead, pause the video, and tell me what the measure of angle FAC is. Okay, so FAC starts right here. And then, wow, I cannot draw today. And then goes right over there to C. Okay, you just follow the points, F to A to C. So there's our angle. Cool thing is this guy actually starts at 0. So that makes this whole really, really easy. So wherever the left side ends, that's the angle measure. So where did this guy end? It ended at 130 degrees. But again, you could also do this too. The left side, the measure is 130 degrees, minus the right side, or the small measure, which is 0 degrees. And of course, that gives you the 130 degrees. And there you go. Now, they will also say, okay, is this angle acute, right, obtuse, or straight? So there's your bonus questions for these. Go ahead and answer for both of these, whether it is acute, right, obtuse, or straight. Go. Okay, so hopefully for both of these, you said obtuse, because the angles are bigger than 90 but less than 180. So there will be that bonus question that you have right there of what kind of angle is it? Acute, right, straight, obtuse. All right. Moving on. So again, like I said, we talk about types. We can talk about relationships. We've got complementary angles, supplementary angles. Complementary, I abbreviate comp. Supplementary, I abbreviate sup. Okay? So with these, again, this shouldn't be unfamiliar. You should know all this stuff. Like I said, all this geometry stuff is very, very straightforward stuff that you guys should know. Okay? Or hopefully remember. If not, I'm going to jog your brain. So complementary, hopefully you guys remember, like, oh, that's when two angles add to 90 degrees. Okay? Supplementary, then, is when we have two angles who add to 180 degrees. Okay? Now, just about these angles, complementary and supplementary, the angles can touch, but they don't have to. Okay? So what I mean by that is I could have a 60 degree angle right here and a 30 degree angle right over here. And 60 plus 30 is 90. So these two angles are complementary. But they didn't have to be apart. I could have a picture that looks like this, where they are touching, or what we call adjacent. Okay? So complementary angles, they don't have to touch each other. They can, but they don't have to. They can be separate. So, for instance, I can have a 30-degree angle, and then Christian, I know he's a student in my class. Christian could have the 60-degree angle, and we are both complementary to each other because Christian has 60 degrees, I have 30 degrees. Together, we add up to 90 degrees. Okay? So they can be separate, but they don't have to be. And the same thing with supplementary. Okay? Supplementary, I could have a 100-degree angle and a 60-degree angle that are separate. Sorry, I said 60. That should be 80. Silly Mr. Armstrong. 80 degree, because 100 degrees plus 80 degrees is 180 degrees. So these two angles are supplementary. But again, they could touch if they wanted to. Okay? Where this is the 100-degree angle. This is an 80-degree angle. So again, they don't have to touch, but they can be adjacent. And this one actually has a special name, which we'll talk about soon enough. So this is kind of a special case of supplementary, which is important to us. You will see this case pop up a lot coming up. A couple other things that when it comes to complementary and supplementary, the biggest thing that plagues students is we forget which one is which. So let me give you some key diagnoses to how we remember this. Remember, complementary starts with C, complementary, and is all about 90 degrees. Okay? Supplementary starts with S and is all about 180 degrees. So, if you're thinking alphabetically, C comes before S. The word complementary would come before the word supplementary in the dictionary. When we count, 90 degrees comes before 180 degrees when counting. So these are in order, alphabetically and numerically. C for 90, S for 180. And then, stealing what one of my students showed me a couple semesters ago, C can easily be turned into a 9 by adding one line. So C, complementary, is all about 90. By adding one line, I can turn S into an 8. So, supplementary is all about 180. So kind of an interesting way. By using one line, I can turn the C into the number that it's going to deal with. By using one line, I can turn the S into the number that it's going to deal with. Okay? So there you go. Kind of an interesting thing. So C is all about the number 9, which is 90. S, supplementary, is all about the number 8, which is 180. So two ways to think about it, alphabetically, numerically, or I can turn these into the number it's about. The C becomes a 9, the S becomes an 8. Kind of interesting. Thought that was cool that a student showed me that. All right, so what you will see in the assignment is they will take some of these and they'll say, here's a measure. So here is the angle 48 degrees. I want you to find me the complement, and I want you to find me the supplement. That kind of looks like an A. Let's fix that. All right. So what they mean is, if I take 48 degrees plus what will give me 90? That's what they want to know. They want to know what this angle is. What plus 48 gives me 90? And then down here, they're asking 48 plus what will give me 180 degrees. Okay? So you just go to your calculator and let it do the dancing for you. Take 90 minus 48, and you get 42 degrees. There's your complement. The supplement, take 180 minus 48, and you get 132 degrees. That's what they're after. Go ahead and try that for 17. Give me the complement and the supplement. Go. All right. So the complement of 17, hopefully you found that to be 1 degree, because you take 90 minus 89, and that's 1 degree. The supplement, hopefully you found that to be 91 degrees, because you'll take 180 minus the 89. And there you go. See, nothing crazy. We're making this simple. Don't let it get you down. All right. Now, then they'll throw pictures at you like this. Okay? Hopefully you all remember what this symbol means. Go ahead and find me the missing angle. Okay. Hopefully you remember that symbol means right angle, which means 90 degrees is there. So that means these two angles are complementary. That's all this was. This was a complementary picture. This is those two angles that are adjacent that I showed you back here, right there. Okay? So they just want you to figure out what is the missing angle. So all you have to do is take 90 minus 25. 90 degrees minus 25 degrees, and you get 65 degrees. That's all they want. Don't forget your labels. These are in degrees. All right? Try this one. Okay, hopefully you remember this picture from what I gave you before. So right back here, this is one of those supplementary because it forms that straight line right there. Okay? And so since they are supplementary, they form that straight line. We're just dealing with 180. These two angles have to add up to 180 degrees because these two angles make that straight line there. So you take 180 degrees minus 34 degrees, and you get 146 degrees. And there you go. Wrapped up nice and neat for you. Okay? All right. So here's where we're going to talk about some angle relationships. And we're almost done. We got these two angle relationships, and then we're going to talk about parallel lines. Okay? So right here, this is that special relationship that we just worked with right here. Okay? We knew that these form that straight line. This is what we call a linear pair. So when you have two angles that are supplementary and they're adjacent, and that's a horrible circle. I'm going to redo that. So two angles that are supplementary and adjacent. In other words, they're forming this straight line that's right here. Okay? When you have two adjacent supplementary angles, they're what we call a linear pair. Linear pairs are very, very important for us in geometry. Forgot what we were doing. I'm about to say college algebra. That's just weird. Linear pairs are very, very important for us. Okay? So two angles that are adjacent and form a straight line, that's what we call linear pair. And since they are a linear pair, hence the word line, we know that these angles, 1 and 2, are always supplementary. That's a no-brainer for us. This picture always produces supplementary angles. All right? Down here, we have vertical angles. So I've given you examples of vertical angles. Angle 1 and angle 4. Sorry, angle 2 and angle 4 are vertical. Okay? Angle 1 and angle 3 are vertical. So vertical angles are what I call two angles. This is Mr. Armstrong's definition. It's not the real definition is very technical. They talk about opposite rays and things like that. It's just all crazy. So what I call vertical angles, when two lines cross, they are the angles that are directly across from each other. Okay? So 1 and 3 are directly across from each other. 2 and 4 are directly across from each other. They're not adjacent. Okay? So two lines that cross each other, they are the angles that Two lines that intersect each other, let's say that. That's a little bit better. Two lines that intersect each other, they are the angles that are across from each other. Okay? So 1 and 3 are across from each other. They're not adjacent. 2 and 4 are across from each other. They are not adjacent. Those are vertical angles. What's cool about vertical angles is that they are always congruent. Okay? Congruent means they have the same measure. So if angle 2 was, let's say, 100 degrees, because angle 2 is vertical with angle 4, it is 100 degrees. If angle 1 was 80 degrees, that means angle 3 is 80 degrees. Okay? Because vertical angles are congruent. They're across from each other. Some other things that we know, and you'll see this notation, I use arches. That will represent that these two angles are congruent to each other. And since 2 and 4 are congruent to each other because they're vertical angles, and they're different measures, I will use 2 arches for those. So we know that these 2 arches mean these two are congruent. They're the same. 1 arch means that these two angles are congruent. They're the same. So I use arches to represent congruencies for angles. All right? So you'll see that pop up. Okay? So that's kind of like how I mark some things up. When you see those arches, it means I'm talking about some congruent angles. Match up the angles that have the same markings, and you know that they are the same. All right? Okay, other things that you can see in this picture, kind of cool. You have vertical angles, and I know that this is 80 degrees if this one was 100, because if you look at 1 and 2, oh, these are a linear pair. So not only with vertical angles, you also get linear pairs. You can also see that 2 and 3 are a linear pair because they form this straight line that's right there. You can see that 4 and 3 are a linear pair, and 1 and 4 are a linear pair. Because again, they're forming those straight lines. So with vertical angles, you also get some linear pair action. So these two are pretty important to us. Okay? Vertical angles and linear pairs. Go ahead and figure out the measure of angle 1, 2, and 3. Okay. So hopefully you found the easiest one first, which is angle 2. Again, they number these 1, 2, and 3. You do not have to do them in the order of 1, 2, and 3. Sometimes it's impossible to find the first angle until we get some other information first, just so you know. Although it's not impossible to find the first angle, but you can actually do these angles in any order you wanted. I could have started with angle 3 first. I could have started with angle 1, but I'm going to start with angle 2 first because it's the easiest for me. It's 133 degrees. How do I know that? Because it is a vertical angle with the original 133 degrees. And vertical angles are congruent. Okay? So these two are vertical to each other. And since they're vertical, remember, we know that they are congruent, which means they're the same. So since this is 133 degrees, so is the measure of angle 2. So now we can work with 1 and 3. And it doesn't matter which one you find next, okay? Because they're both going to can be found the same way. So I'm going to do angle 3 just to make you all mad, okay? So if I want to find the measure of angle 3, what are some things that I see? Well, I know that angle 3 and the original angle, these two, form this straight line. That means they're a linear pair. And linear pairs are supplementary. Okay? So these two angles are supplementary to each other. So if I take 180 minus 133, I know that angle 3 is 47 degrees. And in geometry, you're going to see me do this a lot. You're going to see me mark up my picture all the time. In geometry, I encourage you to mark up your picture. I should have put 133 degrees here because we knew that. And now we know measure of angle 3 is 47 degrees, which now we can actually find the measure of angle 1 really quick. Okay? So we know the measure of angle 1 has to be 47 degrees as well. A couple different ways to talk about this. You can say that it is vertical with the measure of angle 3. And notice I use 2 markings for that because it's a different angle. So you could talk about vertical angles, or you could have talked about, oh, these two are a linear pair. Angle 1 and angle 2 are a linear pair. Or angle 1 and angle 133 are a linear pair. Lots of ways to look at it. What's cool about geometry and what gave most students trouble in high school was you didn't learn the vocabulary. Geometry has lots of vocabulary. And if you know that vocabulary, it's going to help you in the long run, because all of these values we knew because of vocabulary such as vertical angles and linear pairs. Okay? Knowing that vocabulary gives you access to what you're looking at in the picture. If I didn't know that vocabulary, I probably would have looked at this picture and be like, I don't know. I mean, these two look the same, but you should never, ever assume things in geometry because maybe this is not drawn to scale. Okay? So just because they look the same doesn't mean that they actually are the same. Okay? So knowing that vocabulary, I cannot stress this enough. Knowing that vocabulary is a huge help in geometry. And it will be a huge help for you in chapter 10. All right? So make sure that you learn that vocabulary. Super important. All right? And I'm only going to introduce vocabulary to you that you need. I'm not going to give you fluff and stuff. All right? But again, all this vocabulary that we just learned about linear pairs and vertical angles, they all stem back to straight lines, array, adjacent angles. They all go back to that beginning information. We didn't have this information without this. These 3 underlying ideas of points, lines, and planes are why we know so much about this information. Okay? Last but not least, in 10.1, we're going to talk about parallel lines. So this is the symbol for parallel. It looks like 2 lowercase L's or 2 capital I's. It really, if you kind of look at it, it's kind of the symbol of the 2 L's from the word parallel. Okay? And they actually look like parallel lines in here. You know that parallel lines are 2 lines that never touch or never cross. All right. They are it is because of parallel lines that makes our geometry very, very special. Okay. Parallel lines is just kind of give you some background on this one. There is a theory out there that many believe that parallel lines can be proven. Okay. In the original Euclid geometry, Euclid claimed that parallel lines existed because of a postulate. Okay. They believe that parallel lines was a postulate and that we just have to accept that parallel lines exist and we can't prove them. But there are many out there who believe that parallel lines can be proven. So you can Google this. If you can prove parallel lines, man, you could be very, very rich because that would blow mathematicians out of the water. Many people have tried it throughout the year, many great mathematicians. They haven't been able to do it yet, but there is a theory out there that many believe that parallel lines is really a theorem and can be proven, although many have failed when they have tried. So it's kind of an interesting idea out there. And this is what makes our geometry special. If we didn't have parallel lines, our geometry wouldn't be special. And actually, we wouldn't have the buildings that we have today without them. We'd all be living in fun houses. Okay. Floors would be slanted. Walls and rooms would look so weird. Okay. But it is because of parallel lines as why our geometry is so special. All right. Now, when you were in high school, you learned lots of parallel line little sayings, like if 2 parallel lines are cut by a transversal, then such and such happen. So we're going to talk about those such and suches, okay? But I want to talk about what a transversal is. So in that little statement that I said, transversal, if 2 parallel lines are cut by a transversal, this line right here is a transversal. All a transversal means, it's a line that intersects a lot of other lines. So you can see this line right here is what we call transversal because it's hitting these two lines. Okay? So a transversal is just a line that intersects lots of other lines. That's all a transversal is. All right? We just given it a shorter name so that we can do some things. All right. So up here, we have parallel lines. I know they're parallel because I have these little blackened triangles here. So if you do not see these blackened triangles, then you need to make sure that you read the directions and let them know that they are telling you that the lines are parallel. If they do not tell you lines are parallel, then you cannot assume lines are parallel in your picture. All right? That's what I was talking about a moment ago. You cannot assume things are happening unless you know they are happening for sure. That you are either being told them in the directions or they are showing you some sort of symbol that represents parallel. Right here, I'm showing you symbols that represent parallel. In the example you're about to do, I didn't put it on here, but there should be symbols. Actually, no, the directions tell you that these are parallel lines. I forgot that. The directions will tell you that these two are parallel lines, so you can actually find the angle measures. If we did not know that these were parallel lines, we would not be able to do anything with 4, 5, 6, and 7. Okay? We would only be able to know 1, 2, and 3. Okay? So unless they tell us that these are parallel, angle 1, 2, and 3 are the only things that we would know. Once we know these two lines are parallel, then we can figure out 4, 5, 6, and 7. We're going to get to that picture here in a second. So let's talk about this in general. Let's refresh your memory. Let's get a couple more vocabulary words, and then we can deal with that picture. All right? So do not forget that we already know about linear pair and vertical angles. Those are still important to us. We're going to use those. But because of parallel lines, we get 3 other vocabulary words. Let me go to entire page for this. The first one is what we call corresponding. Okay? Corresponding angles. And I would have you guys tell me these in class. I would have you rack your brains left and right to get these kind of the angle names for me because you've all have seen these names before. You learned these in high school geometry. I just got to make sure that you wake up the hamster that remembers these. So corresponding angles. Let me give you examples of these. Angle 1 and angle 5 are corresponding. Angle 2 and angle 6 are corresponding. So what are corresponding? Here's how I kind of deal with those. Corresponding angles are 2 angles that are in the exact same position. Angle 1 and angle 5 are both in the exact same position. When I look at these, I think of these as a group of 4, and these as a group of 4. Angle 1 is in the top left-hand position. Angle 5 is in the top left-hand position. Therefore, they are corresponding. They are in the same place. Top left, top left. If you look at 2 and 6, angle 2 is in the top right-hand position. Angle 6 is in the top right-hand position. Okay? So these are in the same spot. What other 2 angles or 2 sets of angles are in the same position? Hopefully you said that angle 3 and angle 7 are corresponding. And hopefully you also said that angle 4 and angle 8 are corresponding. Okay? Because angle 3 and angle 7 are bottom left-hand corners. Angle 4 and angle 8 are bottom right-hand corners. Okay? Basically, what we're doing here, why parallel lines helps us out a lot, is it's given us a way to relate these 4 angles to these 4 angles down here. I call these angle hopping ideas because I can hop from angle 1 to angle 5 because they are the same. I could hop from angle 3 to angle 7 because they are the same. Okay? I call these angle hopping ideas because they allow us to relate the top 4 angles to the bottom 4 angles. It's really cool. Okay? What is cool about corresponding angles is that all corresponding angles are congruent. So whatever angle 1 measures, that's the same angle measure as angle 5. Whatever angle 4 measures, that's the same angle measure as angle 8. So corresponding angles are always congruent. Okay? So our next set of angles we're going to talk about are alternate interior angles. Okay? Alternate interior angles. Let me give you an example of alternate interior. Angle 3 and angle 6 are alternate interior angles. Okay? So what I defined as alternate interior, your parallel lines divide your spaces up here. When you are between your parallel lines in here, this is what we call the interior. Out here is what we call the exterior. And there are two exteriors, one at the top, one at the bottom. Okay? So interior is between my two parallel lines. I think about it kind of like everybody in here is in jail. These angles 3, 4, 5, and 6 can't get out because there's nowhere to go. You've got the transversal in here, you got up and down, okay, nowhere to go. You're always trapped between these two walls. Okay? Exterior angles, I think these are like on the outside of the jail because 7 has all this space out here to go. It can extend, to the left, but it can extend down this way. It's got room to go. There's no stopping it. And the same thing with 8. It has all this space out here. It can go. It's not really confined. Okay? And the same thing for 1 and 2. It has all this space up here 1 can go, and all this space over here that 2 can go. Okay? So interior is bouncing between the two lines. Exterior, it's only got one wall that's stopping it. Okay? It's got all this other space out here. All right. So that's how we talk about interior versus exterior. Now, we call these alternate because alternates are on the opposite sides of the transversal. They're not next to each other. Okay, these would be adjacent, but they're on opposite sides. All right. So this 3 and 6 are across and on opposite sides from each other. What is another alternate interior angle set? Well, hopefully you said angle 4 and angle 5 are another alternate interior set. Because again, they are across from each other on opposite sides of the transversal that's here. Okay, and they're interior. So these are what we call alternate interior angles. All right. They are across from each other, comparing the top 4 to the bottom 4. Okay. They are never side by side. So 3 and 4 are not alternate interior. 5 and 6 are not alternate interior. Hopefully you know what 3 and 4 and 5 and 6 are. Hopefully you know that 3 and 4 and 5 and 6 are what we call a linear pair. All right. So if we have alternate interior, that means we also have alternate exterior. So this is the last set of angles. Alternate interior, what is special about them? They are also congruent. So whatever angle 3 is, angle 6 must be the same. Whatever angle 4 is, angle 5 must be the same. And then last but not least, as I said, alternate exterior. So we can talk about angle 1 and angle 8. And we can talk about angle 2 and angle 7. Again, the only difference is that these are exterior. So 1 is opposite the 8 on the other side of the transversal. 2 is opposite the 7 on the other side of the transversal, and they're exterior. And the same with these that were interior, exterior has that same relationship. They are congruent. So whatever angle 1 is, angle 8 must be that. Whatever angle 2 is, whatever it measures, angle 7 must have that same measurement. Okay? So these are the 3 new vocabulary words, along with linear pairs and vertical angles. So if you look at all this, you have 4 relationships that are congruent. Vertical angles are congruent. Corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. You have only one relationship that is supplementary, and that's the linear pair. Okay? Linear pairs are supplementary. They add to 180. So we're going to use that information to help us answer these 7 angle measures. But before we get to that, I do want to talk about some other one other idea. There really is another angle relationship that we could talk about in here. It's what we call consecutive interior angles. So 3 and 5 are consecutive interior. 4 and 6 are consecutive interior. Or another way that we would call them, which I would use, which is more descriptive, we call them same side interior. So 3 and 5 are same side interior. See, they're on the same side of the transversal. 4 and 6 are same side interior. They're on the same side of the transversal. I like to call them same side interior because it's more descriptive of what they look like. So 4 and 6 and 3 and 5 are what we call consecutive interior angles or same side interior angles. What it means to be consecutive interior or same side interior, it means that they are supplementary. So there is a 4th relationship that you could talk about, same side interior angles, and they are supplementary. You don't have to know that if you don't want to. It's just, food for thought. You did learn about it in high school. And there actually is a 5th one, although it's not normally recognized in textbooks, but there are a few and far between textbooks that do talk about it. If you have same side interior angles, you also have same side exterior angles. So 1 and 7 are same side exterior. 2 and 8 are same side exterior. And those are also supplementary. So again, those are 2 extra ones you can talk about if you really want to. We don't really need them. I'm giving you the only stuff that you need them, but I want you to know they do exist. So same side interior, like 3 and 5 and 4 and 6. Again, they're supplementary. Or same side exterior, like 1 and 7 and 2 and 8. And again, those are also supplementary. But again, you don't need those if you don't want to. But I do want to mention them because they do exist. Okay, so go ahead, pause the video, think about those 5 vocabulary words: corresponding, alternate interior, alternate exterior, linear pairs, vertical angles, and figure out each of these 7 angle measures. Again, you do not have to start with angle 1. You can do whatever angles you want to start with. And go. All right. Excuse me. So, what I usually start with is I take care of all my congruent angles I know right away. So, my first angle that I would deal with is angle 3. And I know that it is 112 degrees. Okay? I'm actually going to zoom in on this. We know that this is 112 degrees. Reason being, these are vertical angles. And in class, I always ask why you know this. Because if you know the reason why you are saying it's this measure, then, if you know why they're congruent, if you know what they are, then you know why they're congruent. We know that this has to be 112 degrees because these 2 angles are vertical angles. Vertical angles are always congruent. So if you know what the angles are, if you know which one of those 5 vocabulary it is, then you know why this is happening. And I think that's so important to know why this is true. Okay? So we know angle 3. You could have started with angle 4 if you wanted. And we know that angle 4 is 112 degrees. And again, I would always ask why. Okay? So some reasons why we know angle 4 is 112 degrees. Well, 112 and angle 4 are corresponding. Top left, top left. We also know that angle 3 and angle 4 are alternate interior angles, which are automatically congruent. So that's two reasons why we know angle 4. Again, you don't have to really know the reasons. It's not going to ask for it on the assignment, but if you know what they are, again, that's why we know that it's 112 degrees. So the last angle we know that is congruent real quick is we know that measure of angle 7 has to also be 112 degrees. And notice I marked all those with the same markings. So all these that have that one arch are all 112 degrees. Now, the reason we know that angle 7 is 112 degrees, lots of reasons. You could talk about how these two are vertical angles. You could talk about how 7 and 3 are corresponding, bottom right, bottom right. Or you could talk about how 7 and the original angle are alternate exterior angles. And alternate exterior are congruent. So 3 different reasons why we know that. Notice I'm not even going in order here either. We did 3, 4, and 7. Now I'm going to go back and do angle 1. Okay? So if I look up here, you've seen this before. Oh, it's forming that straight line right there. This is where you're going to use linear pair. You have to use linear pair once in this picture. Okay? Because that's how you're going to get the second angle. So we know that 112 degrees and angle 1 are supplementary because they are a linear pair. So if you take 180 minus 112, we know that the measure of angle 1 is 68 degrees. And now it's all over but the crying. Hopefully you realize the rest of these angles should be 68 degrees. Okay? So the measure of angle 2 is going to be 68 degrees. Reason why we know this is because angle 1 and angle 2 are vertical. Or you could say 112 and angle 2 are a linear pair because they are. They form this straight line. Or you could say angle 2 and angle 3 are a linear pair because they form that straight line that I have circled up there. See, lots of reasons why we know that. Okay? Then you could say that the measure of angle 5 is 68 degrees. Reason we know that that is 68 degrees because 1 and 5 are corresponding. 4 and 5 are a linear pair. 7 and 5 are a linear pair. Angle 2 and angle 5 are alternate interior. Lots of reasons why you know that. If you know this vocab, it makes things so much easier for you because knowing the vocab, geometry is really about all what you know. And if you don't know that vocab, it makes pictures like these hard. But knowing that vocab just made this a whole heck of a lot easier. And last but not least, we know that angle 6 has to be 68 degrees. Again, for a myriad of reasons. Okay? Vertical angles. Linear pairs between 6 and 7. Linear pair between 6 and 4. Alternate exterior between 6 and 1. Corresponding between 6 and 2. Okay? Lots of different answers. Know that vocab, guys. I promise it's going to make this thing a whole heck of a lot easier. And that right there wraps up section 10.1.